Assalamualaikum warahmatullahi wabarakatuh. In this video, we are going to focus on the distribution function, or known as cumulative distribution function of x, when x is actually continuous. Okay, so when x is continuous, we can find what is CDF. Remember what is the idea of cumulative? Cumulative means basically the value is just going to keep on increasing due to some sort of successive addition, yes. And in the case of continuous random variable, so the value here of this function is going to keep on increasing. Yeah, let me just write it down. So in the case of x being a continuous random variable, the notation for CDF is the same. We use big F or capital F, and this is also similar. So the idea is that we want to find what's the probability of our random variable here. So this is our random variable, taking the value of small x or less than that. And I hope that you still remember what we have done in the case of x being a discrete random variable. When x is a discrete random variable, we have this notation to say that this is a CDF. This is a CDF, cumulative distribution function, which means that you're going to find probability of our random variable x being less than or equal to this specific value here, small x. And in order to find this probability, what you have to do is you're going to add up all the probabilities related to the value of x here or smaller than that. So the process involves is addition, and we use this notation here, sigma. Okay, now for the case of continuous random variable, so this is the case of continuous random variable, we have this one, which is also the same notation as x being discrete random variable, and this is known as CDF. But for the case of continuous random variable, we are going to have the probability density function integrated with respect to this one. We have this lower limit and up to x, the value of x. So here, notice that the probability density function here is expressed in terms of another variable or another notation. We use t. Okay, so the probability density function will be expressed in terms of t. We will see example later on, and I hope that this idea will be better understood by the time we do the example. Okay, now similar to what you have seen in discrete case, the distribution function, okay, big fx here should fulfill the following properties, and this have already been covered in the case of discrete random variable. Okay, next is if you want to find the probability of our random variable between a and b, being between a and b, what you can do is you can consider the cumulative distribution function for point b. Okay, and you're going to minus the CDF or cumulative distribution function for point a. So by doing this, you can get this probability that you're looking for. Now, another way of doing this, as you have seen in the previous video, one way of doing this is if you have the probability density function fx, now you can integrate that with respect to dx, and the limit here will be supplied as such. We have lower limit of a and upper limit of b, and by doing that, you will also get the probability that you're looking for. So there are two ways of doing it. Either you're using density function, or you're using the CDF. Okay, now let's say you have been given the CDF, and you want to find what is this probability density function, PDF. Okay, so what you can do is you can differentiate the function and you will get fx. Now basically, let me just write it in a simple form. If let's say you are given PDF, this is probability density function, and you want to find what is CDF. So in order to find CDF, this is what you have to do. You have to integrate this function. So you have to do integration process. Okay. So now if the reverse is given, for example, the CDF is given, and you want to find what is the PDF, probability density function, what is this? Oh, in order to find this, you need to differentiate this function here. Okay, so that's what's going on. Okay, now let's look at this example right here. We're going to find the distribution function of x. That means you're going to find the CDF. Another word is CDF in example 3.6 and use it to evaluate this probability. So we're going to find what is big F of x, and we're going to use it to find the probability of x being in between 0.5 and 1. So remember the probability density function in example 3.6 is this one. Yes, this is the probability density function for x greater than 0, for x greater than 0. Okay, so that's the expression, that's the value of x that we have to consider as lower limit and upper limit later on. Now in order to find big F, we need to do integration. We need to integrate this function right here, and before we can integrate this function, okay, we need to switch the representation here to the value of t. We're going to use a new representation, which is ft is 3e negative 3t. So we're going to use this representation now, and then we can continue with what we need to do, which is to find the big fx. This is going to equal to integrate this function 3e negative 3t dt. The limit here is going to be what's the lowest limit? So the lowest limit is 0. You can see that the lowest limit is 0, and the top part is going to be equal to x. Okay, so this one follows directly from what's given here. Okay, 3 is a constant, so we have this one. Okay, e negative 3t dt, and we have seen this, so we know how to do this integration. What we have is we can let u be equal to negative 3t, therefore du dt is negative 3, and therefore dt is du over negative 3. And we're going to substitute this into this equation. So I'm going to call this 1. Okay, 1. So alright, what we're going to do next is we're just going to continue. Therefore 3x0, this is can be written as 3 EU, and here we've got du over negative 3. Okay, and you can simply cancel this with outside. 3 and 3 can be cancelled out, and we have negative EU du, and we already know what's the result of this integration. It's going to be the same EU. So I'm just going to write back the answer. It's going to be EU. But what is U? U is actually negative 3t. So this is what I'm going to write down. And I'm going just to consider the limit associated with this one, which is x and 0. Then I'm just going to express this in terms of positive exponents. So I'm going to have e 3t x and 0, and we're going to substitute the values here into t. So we have negative 1 over e 3x minus 1 over e to the power of 0. Okay, and here we've got the answer here is going to be maybe, let me see, negative 1 e3x plus 1. Okay, or we can write it in terms of 1 minus 1 over e 3x. Okay, so this is the answer for x greater than 0. This is how you can write this answer. Okay, either looking like this or like this, doesn't matter. So we have the CDF written in this manner. The value here is 1 minus this one, e negative 3x for x greater than 0, and it's going to be 0 for x less than or equal to 0. Okay, so that's what we've done here. Next is we're going to use the result that we got here in order to evaluate the probability of x being in between 0.5 and 1. Alright, so I just erase this part over here. Okay. Okay. Now let's move on to the next question, which is to find the probability of x in between 0.5 and 1. And this is equal to, since we have found what is the value of CDF of x, we can use this result here. Okay, so we have f, we need to find 1 minus f 0.5. So what is f? This is our f CDF for x. Okay, this is our cumulative distribution function, and I'm just going to substitute the value of 1 into this function, also the value of 0.5 into CDF here. Okay, so we have f1 is 1 minus 1 over e, 3 times 1 is 3, minus, so going to substitute 0.5 into this, so you have 1 minus 1 over e, 3 times 0.5 is 1.5. Okay, and then we can simplify the whole expression. You can take out the bracket and so on, so you will see that this here will be cancelled out, and we will have negative 1 e, this one is 3, and it's going to be plus 1 e, this is 1.5. Taking out your calculator and punching in the number, you should be able to get that the result is 0.1733. Okay, right. Next, we're going to move on to the next example here. This is the last example related to the cumulative distribution function for continuous random variable. Okay, so in this example here, the information given is CDF. Okay, this is the information given, and you are required to find PDF, probability density function, PDF, also mathematically represented as fx. Okay, the small f. Right. Now, in order to get the PDF, we need to differentiate CDF. Okay, so we're going to consider each interval. So for example here, if we consider the interval for x less than or equal to 0, in this case big F x is 0. Therefore, in order to find the PDF, we need to differentiate this function, and this function is 0. So if you differentiate 0, you get 0 constant. Yeah. Okay, so that is the first part for x for this interval. Okay, we've got that result. Next, we're going to focus on this part. Okay, this for the second set of interval, we have x between 0 and 1, and so in this case the CDF is described as equal to x. Therefore, in order to get the PDF for that particular interval, we are going to differentiate this function here, which is just x. So differentiate that, you will get the result equals to 1. And finally, you can consider this part here. Well, for x greater than or equal to 1, the CDF is just 1. And therefore PDF for that is going to be differentiating the value of this, which is 1, and you're going to get a constant equals to 0. Okay, so you get differentiate 1 is going to be equal to 0. Therefore, this is how you can write the answer, the final answer. You can see that 1 is for this particular interval for x between 0 and 1. 0 is elsewhere. Okay, well, you can see that for x less than or equal to 0, the answer is 0, so we cover that range. And then for x greater than or equal to 1, the answer is going to be 0, so that's how we can write this result here in terms of 0 elsewhere. Okay, next we're going to plot the graph of fx, the CDF and the PDF. Okay, so for CDF, this is how it's going to look like. Well, you may want to try this on your own first. You may want to pause the video and try sketch the graphs and see how it compares with my answers later on. Yeah, okay, right, this one which is based on the information given here. Now I'm going to just consider this axis here. This is x, this is big F. Okay, we have the intervals for x 0, 0 and 1, greater than 1, so this is 0, this could be 1. Okay, and when you have okay, so this is, let's say, 1. Okay, now when you have this part here, it's going to be 0 for x less than or equal to 0. Therefore 0 is included. I'm going to use the full circle. Let's go in this direction. Okay, for x being 0 and less than that, so in this direction, so it's like this. Okay, next for x between 0 and 1, the value is x, the function given here is x, so basically it means you're going to get a straight line. What does it mean, fx is equal to x? Well, it means something that you have seen before. This is actually the graph of y equals to x, where it basically means that you're going to get a straight line that looks like this, where each value of x is equal to each value of y. For example, if x is 0.5, y is also going to be 0.5. If x is 1, y is also going to be equal to 1. And since the interval is just between 0 and 1 is not included, so we know that it's going to be open circle here, because at this point 1 is not included. Okay, and the graph is going to look like this. Okay, straight line. And when x is greater than or equal to 1, the value here is going to be 1. Therefore, at this point, we're going to have full circle and we're going to go in this direction. Okay, so that is how the CDF looks like. Now let's move on to the next part, which is plotting this value, which is this one. Okay, well, this is quite easy to plot. This is x and this is small f, and we have x between 0 and 1, so we got 0, we got 1, and the value of fx is 1 and 0 elsewhere, so maybe here is 1. So what it's saying is basically for x between 0 and 1, you're going to have a constant value of fx, which is just 1. Okay, if you want to plot that on the graph, at point 0 here, it does not include 0, x greater than 0, so the value is equal to 1, so it's looking like this. We will use this open circle, and it's going to be equal to 1 for all the value, for all x in between 0 and 1. And when you reach this point here, it doesn't include 1, so you can see that x is less than 1. So again, at this point, we're going to use open circle. Okay, so that's how it is. I think that's all for now. Thank you very much for watching.